Hi everyone, am I audible? Hi, welcome everyone and good evening. Thank you for joining us for today's webinar. My name is Deepika Singhal and I'm the Community Manager at Analytics Vidya. Analytics Vidya, as we all know, is the leading community of data scientists in India and across globe. Today, we are hosting a webinar on analytics, on machine learning and advanced analytics in smart cities, presented by Hariharsudhan Balasubramanian. Hari is a data scientist graduated from the National University of Singapore and is currently working for the Smart and Safe City projects in Singapore. Let me get Hari on board. Hi, Hari.
Hello everyone. Am I audible?
Yeah, thank you, Hari, for joining us.
Thank you. Thank you, Deepika.
For all the attendees, if you have any questions during the webinar, please type them into the Q&A section. Also, before we start the session, I'd like to have a poll session. Guys, you can vote on the poll. Guys, few more seconds and we shall start with the webinar. Please put in your answers for the poll. Also, if you have any questions during the webinar, you can post them into the Q&A section of the platform that you can see. Okay, we shall end the poll now. So we had two questions. How many years do you have experience do you have in data science and analytics? So it's most like 90% of the people who have less than 3 years of experience, and most of us we haven't worked on smart city projects. So I hope this webinar is very useful to all of you. Okay, over to you, Hari. You can start the webinar.
Thank you, Deepika.
I'll stop screen sharing. Yeah.
Is everyone able to see my screen? Okay, yes. Guys, today I'll start with a little bit of introduction about me, and then we'll look into the presentation. So I started my data science career as a student in National University of Singapore, doing a lot of modules in data analytics, machine learning stuff, and using them for real-time projects and in building intelligent systems that can help do some business analytics tasks automatically, building expert systems and all kind of related steps. And as okay, I'll be allowed. And then I started my career in job perspective, first with IBM Smarter Supply Chain Analytics, the Center of Competency in Singapore. It was a research role. So I started my career as a researcher in social media analytics, pulling data from social media, and then doing some text analytics on top of that, and using it for some prediction steps and other analytics steps related to the supply chain division of IBM. And then I was working for intelligent transportation solution company for 2 years plus, and I was completely involved in the smart city related projects during that experience, and followed by my experience with NCS, which is National Computer Systems in Singapore. I'm still working on the smart and safe city domain, and so to say, I would say my experience is more on the smart city related stuffs and intelligent transportation solution related stuffs. And so let's go with the presentation now. And today's presentation, we mostly concentrate on understanding what is a smart city and what is not a smart city, and what are the stuff that makes a city smarter, and what is the need for smart city, why do we need to have smart city. And by the end of the session, I believe everyone would have a clear idea of what is a smart city and what makes it smarter, and then some real current scenarios on the machine learning and advanced analytics projects which is happening right now on many smart cities, including Singapore, and then what is coming in the near future, and how much can it extend, and what could go on in the future. And I believe everyone will have some idea about what are the things we can concentrate to work towards a smarter city everywhere, and bringing better life to people everywhere. So let's start with some trends here. This is a normal Google trend search on analytics and smart cities. As you see, the red color denotes the number of searches in Google related to data analytics, and the blue related to smart cities. If you see, after a certain time, there is a little bit of correlation between these two. Something like after some time, they both grow, the searches increase with relation to each other. But then it doesn't mean anything, just an interesting fact to look at, because correlation doesn't mean any causation. So there is we cannot associate any reason between this correlation, but still it's just an interesting fact to see. And then if you see, when it comes to searches on smart city in Google, people, the most relevant and related queries are smart cities India, kind of. So it somehow tells us that people in India, or some data scientists or researchers in India, are concentrating more on understanding the smart cities and something like that. And on the other side, it is data analytics, Google Analytics, big data analytics, and everything. So this tells us something. I like to use this slide to clarify a myth that when it comes to smart cities and projects in smart cities, it need not be always having a lot amount of that data, or it is not necessary that we should need some big data and do some big data analytics stuff so that it's considered as a smart city project. We can also do something which is useful for the community, which can improve the lifestyle of people with a minimal amount of data, which is just data analytics, which is not big, is also considered as a smart city project or something related to the smart city. Mm, So by the end of this session, we will be able to answer all these questions. But then the questions are like, what makes a city smarter? Some people think that having open data, government-related data, or any data related to the city, putting it in the open platforms, which is accessible to any common citizen to do research on that, is some initiative for smart city. And some people think good education makes city smarter, and good smart parking bays with some intelligent systems for that, and then smart lighting, efficient energy, the government services online, like tax filing online related services, and intelligent transport cards, which people use to transport, not getting tickets, just tap the card and continue with your travel, and having Wi-Fi access all over the country, and many steps. All these mm, can make a city smarter, but not necessarily. The answer could also be yes, and it could also be no in some cases, because what matters here is not the technology we use or how much smart the lightings are, but how much it contributes to the betterment of people's life is what matters here. So in that context, the main idea of smart city here is not using technology, which is another myth. Many people might have some idea like using high-end technologies in some countries, which are very expert and advanced disruptive technologies makes the city smarter, but it's not. It's not. Um, Smart city initiatives can be out of technology. Technology is just an enabler which helps to make cities smarter. But using only technology cannot make the city smarter. It has to bring something valuable to people's life, and smart city is all associated with people's life, like making the place better to live every day is what smart city is all about. The smart city concept is implemented in different domains, as you see, the buildings, on the natural resources, on the mobility of that, education departments by the universities, and uh, in people's culture, living culture, and government policies, and everything. So there has been many domains where smart city concept is being implemented, and everything contributes to the growth of the city or nation in case of Singapore. And some of the characteristics of smart city is we can call a city smarter if most of these aspects are satisfied. Meaning the city should also have smart people, smart living, smart governance, and smart environment, smart mobility, and smart economy. It need not have everything, but still most of it should be there, so we can call the city a smart city. I'll speak more about this particular domains in later sessions. Now we'll move on from here. And this is a chart which explains the percentage of urban population. It's not the total population in the world. It is the percentage of urban population, which means people living in the cities across the world in 2011. As you see, the red dots here mention the cities which has population more than 10 million. You can see a lot, but still fewer when it compared to the future. So I'll show you another slide, this one, which is a prediction for 2025. And if you can see, if you can compare both of that from the previous slide to this slide, you can see the number of red dots drastically increasing, especially in Asia, which means as time passes, more number of people will tend to move towards cities for their living, which means cities are going to be congested, and especially in Asia, because it's growing vastly now, there will be lot number of cities which will face abundant population coming inside. So to be more clear, this graph would give you an idea of three different years in time. One is in the past, 1950, and 2011, and then the future prediction for 2050. If you can see, this also tells only about the urban population. It does not deal with total population of the world. It says the population, the urban population across the world is being distributed in this manner, where you can clearly see in Asia, in the upcoming years, the total, the distribution of total urban population will be more in Asia, which means 50% of all the people who lives in any city in the world will be inside Asia, which actually tells us, gives us a clear picture of how much population is going to increase in the cities in Asian countries. So which is also which opens so much of opportunities, at the same time which also opens so much of threats which needs to be addressed, and that is why we need smarter cities to face some challenges which is going to occur in future. That's why every country is trying to build their cities smarter and take many initiatives on smart city projects. As you can see, when this increase in population happens in the cities, there will be a lot of challenges which we need to face. Few of them being the population explosion and high cost of living, of course. And when the population increases, obviously the crime rate in the cities will increase. And we need a massive amount of investment to actually build the infrastructures which is required to manage and all the stuffs. Yeah, somebody mentioned water scarcity. Yes, of course, it's going to happen. An exponential growth of data, because everybody use something and create data every day from the smartphone, from the internet, and everywhere. And the data generated nowadays is growing exponentially, not even multiplies, it just exponentially grows. So we need to find ways of handling those data efficiently, and all of those data need not be useful, but there is definitely useful stuff inside every data being generated. So we need to find ways to handle this data efficiently and extract the useful information out of those bunches of data efficiently, cost effectively, and everything. And this drastic increase in population will also lead to a lot of cultural clashes, which might not be addressed using technologies. I included this particular point to explain it, that any problem related to smart nation, it need not be solved using technology. There are many problems which we can handle outside technology, which is also related to smart cities. So we should learn something, not to confuse between technology and smart city. Technology is just an enabler for smart cities. And I have a question here, like when this population increases, the density increases, what do you think will be the effect on the energy consumption in the cities? Whether does it grow proportionally or inversely? Kind of when the population increases, do you think the energy consumption also increases or decreases? We might have different opinions, but still, in actual case, I'm getting some, yeah, people say increases, it's proportional. So most of you reply that it's directly proportional, which is a bit contradictory. Looking deep into that, yeah, it's actually inverse. Looking deep into that, when the population increases in a city, the total amount of energy used will increase, obviously, yes, but the per capita usage of energy will decrease. To make it much clear, let's say we have a bus and the density of the travelers, passengers increase in the bus. It means the resource used is shared by more number of people, which is for per capita consumption of fuel or energy is less. So actually, when the answer for this question would be inversely proportional, because when the density of a city increases, actually the energy consumption per capita is decreasing. But we should find also some ways to efficiently manage this energy, and which is a very big challenge for smart cities, because the main aim is to save some energy for future generations. So which means it's very essential to work on the energy sector to manage the energy consumption in smart cities in future. And this slide would give you an overview of what are the cities ranking top in smart city categories. And all of these cities are doing a lot of stuff related to smart cities. And you can find Singapore in around rank 22. So which is Singapore is working more on smart city projects. Singapore likes to become the world's first smart nation. So obviously we can see drastic improvements. In this presentation, after this slide, whatever I'm going to speak will be much related to Singapore, because my exposure is more relevant to Singapore scenarios. But then it will actually, India's position in this is, somebody asked a question, I'm not sure of it. It's not in top 100, I think. There's no cities from India in top 100 as far as I know, but we will get there, don't worry. And so whatever I speak will be much on the Singapore scenario, but it can be applied to any smart city across the world, especially in India, because a lot of things is going to happen in future. So whatever you can leverage from this session can definitely utilize that in future for any smart nation projects in India. Moving on from here, let's come to the data analytics picture for smart cities. So by now, I assume that most of us have a little bit of good understanding on what is a smart city and what is not a smart city. What works will actually contribute to smart city, and what works do not contribute much. Let's come to the data analytics scenario, which also includes machine learning steps. Any computational analysis we do with data and then come up with some useful information, not just information, some useful information, we can classify the process as a data analytics process. So this, what you see here now is called the DIK pyramid. Later in time, they added another word called wisdom on top of it and made it a DIKW pyramid. The basic idea is to do a little bit of brainstorming on how knowledge is being extracted from data. So initially we collect data from different means, major source nowadays being the sensors, and then we process that data to extract some meaningful information out of the data. And then when we use that information, and we actually come up with some knowledge. Whatever we extract from data is just information. The efficient way of using it is actually the knowledge. And knowledge in action to the real world is defined as wisdom. That's what all the slides is about. This is just to give an overview of the DIK pyramid, which might be useful, I think. Let's come to the other side. When we come to the data analytics projects, we can classify it into many different types, especially 4 actually, but I have mentioned only 3 because the first thing, descriptive analytics, deals with whatever happened in the past, which means we collect data on what happened in past and do some data analytics to understand some patterns on what has happened and think about utilizing these patterns identified so we can come up with some information we can use for future. So basically it answers what has happened in the past. It is called, we can classify that as descriptive analytics. Well, there is one more after this between descriptive and predictive, but let's go to the predictive. Predictive category is something which helps us to answer the question what could happen in the future, which is different from the descriptive analytics. We still use the past historical data. We come up with some models. We train some machines to understand some patterns and use these patterns to forecast future occurrences. Uh, it can be a sales prediction. It can be a stock market prediction or whatever it is. It can be any future occurrences. We try to predict that and use that information and act accordingly based on, let's say, for a company on sales, if we predict there is going to be less sales on this particular regions, then it would help the companies to concentrate on that particular regions to manage it efficiently and tackle the situation without losses. Let me look at the questions a minute. I will let us discuss about the questions in the Q&A session. Let me complete the presentation first, and then we will have much time to discuss if I finish it faster. And in predictive analytics especially, no predicting algorithm, statistical algorithm, can be 100% accurate, because it is a prediction. It can never be 100% certain. We come to the next category, which is prescriptive, which is much advanced, which answers the question, what should we do to address some scenarios? So basically, if you see, we use the past information to understand what has happened, and then we try to use that patterns to predict the future occurrences. And now we speak about what can we do to address the future occurrences. Let's say if we come up with some prediction on sales drop in a particular region, we not only stop there, we also give them suggestions on what can they do so this occurrence could be changed and the profit can be matched. So that comes under prescriptive analytics. So it is very efficient when it comes to prescriptive analytics, which I can say, we not only tell them what is the problem you will face, we also tell them what is the solution for this and what are the multiple solutions for this, and what will be the outcome of every solution. And I leave it to you to decide on which solution you're going to proceed with. So this is an overview of these categories. And as I said, we have one more thing in the middle, which is after descriptive analytics, it is diagnostic analytics. Descriptive, it actually tells us what has happened. Let's say we analyze and answer some questions like which region have the maximum profit and which particular product has sold most everything. But the other part here also deals with the history data, the diagnostic analytics. What does it concentrate? It gives us answer for the why question. Let's say I have, let's come to another scenario. When it comes to healthcare, most of the cases we deal will be the diagnostic analytics. I would say any doctor you go and visit is actually doing a diagnostic analytics. If you incorporate the knowledge of a doctor into a system and create rules or create some decision trees out of the knowledge base you have built, you can actually build an intelligent system that can act similar to a doctor. But still, because it deals with people, any system with any level of accuracy for now will not be approved to act as a doctor. But it can always be utilized as an assistant for doctors to make efficient decisions. So that's the diagnostic analytics part. And then higher thing is predictive analytics, and then the prescriptive. So if you see, the first two will be more on the hindsight, and the predictive will be on the diagnostic, and predictive will be somewhere on the inside, and the prescriptive is completely on the foresight area, which means we see future on what will happen on what we do and suggest people to try adjust stuffs to minimize their losses. Moving on from here, let's now start speaking about the data analytics and machine learning stuffs involved in Smart Nation. And there are many different domains, as I said earlier. We have seen some characteristics in previous slide, which tells us about smart mobility, smart buildings, smart society, smart people, smart retail, and every stuff. Because of some time constraint, I cannot concentrate much on all the domains, but I will start with smart mobility sector. We will see some of the stuffs which had been implemented already, which is existing, and some of the stuffs which is on research, which is going on, which we will see in near future. And we will take up two cases specifically, not into much technical details, but mostly on the functional details to understand what are the stuffs happening in smart cities. And then, if time permits, we will discuss more on different domains and on what is happening and what could happen, what can we concentrate on for future and everything. So let me start with the smart mobility first. Mm, Everything here I speak is in Singapore context, but you can correlate it with any smart city because it's happening in many cities across the world. It happens in Europe, it happens in um, Australia, everywhere. So on this slide, you can see a bunch of images. On top left, you can see the BKE PIE jam to KJE, which is a digital LED board on the highways, which gives information to people about mm, where exactly the jams are and how can so the people can make uh, informed decisions on rerouting their travel using another expressway or deviating from that route to other route so they can save time, avoid congestion, all this information. Um, how does this come? We'll speak about it later. Let you know something about this, and then we go to the phase where the data is being collected, what is happening. We'll see about that later. And next to that on the right, you see a red box. I have marked it on red, which actually it is not much clear here, but it is actually the number of lots available in car parks, in the nearby car parks. So basically it is a board which has the car park names or the building names and then have the number of car park lots available in that particular parking. We will speak more about this later, so keep a note on that. And the next row, you can see your speed is 49 and the maximum speed limit is 50. This is a simple speed detection camera which detects speed from the vehicles and display it so they can have some effect on controlling accidents and making people obey the maximum limit rule. Because when you drive over speed and if you see your speed is over and someone is from the government especially is detecting that, you tend to slow down, right? So something like that. And next to that you see is a map of Singapore with traffic layers, which is a monitoring dashboard kind of thing, which has real-time, or I would say near real-time information on the traffic condition all over the road segments in Singapore. Singapore actually monitors every single road segment and it has information about every single road segment and it is being monitored in near real time. And next to that, you see is a tapping device, which you can see in public buses, where the smart passenger cards is being tapped for travel. We don't buy tickets; we just top up the passenger cards. We tap. It exactly works in the way like the metro rails in uh, India also. The same card is being used for road transports, be it train or bus. It's the same card and all the system is integrated. And below that you can see on the left is the bus numbers and the arriving time for the bus numbers, which is a board, digital board you can see in bus stops in Singapore, which gives people information about the arrival times of this bus. This information is also available in mobile applications, which helps people to plan their travels ahead. Let's say if I know that the next bus to my stop is 15 minutes later or 10 minutes later, I can utilize 5 minutes in home rather than waiting in the bus stop, something like that. And when you come to the two separate images on the right side, the first one is a traffic light, it's a button which people press here, and then they see the green man, so they cross the road. It's a traffic light signal crossing. But if you see, there is a tapping area above this, which is actually for senior citizens or people who use the wheelchairs, who cannot walk faster, to use their concession cards. If they tap it, the green man will stay for longer time. That means the time allotted for crossing the road will be more than usual, so they can conveniently and slowly cross the road, which does not deal much with big data or data analytics, as I said earlier, but it gives some comfort to the citizens, to the people living, to the residents. So it is actually a part of Smart Nation initiative. And next to that, you can see near real-time traffic updates on the roads, on highways, on everywhere. With this board actually gives information about which particular lane ahead is being blocked, and the congestion is between which two segments of the road. You can see H-front AVE is Harbourfront Avenue, and on the top you can see Sentosa Gateway. So between these two road segments is where exactly the congestion has happened, and the people are able to drill it down to the particular lane on which congestion is happening. So this kind of near real-time information is being populated across the roads and expressways for people to leverage it for planning their travel and making informed decisions. So these are steps which are happening right now, which are smaller steps. Will now look more into the ITS sector and vision of Singapore. So this image gives you an overview of what Singapore actually aims to achieve and has achieved almost everything here. A little bit to go, which Singapore is expecting to achieve by 2030. So if you take a look at this, I have marked few steps in red boxes, which we will be speaking about in later slides as well. But still we need to look at other steps as well. So you can see a box with intelligent fleet management system, which is outside the buses. I believe you can find that. You can find that, right? Slide is not visible. Is my slides visible? Are you people able to see? Okay, yes, okay. So thank you. So you can see that intelligent fleet management system. ITS stands for Intelligent Transportation System, or you can say Intelligent Transportation Solutions, whatever. So this is tracking the buses. The bus you see there is the public transport. Tracking all the buses and getting the locations of the buses to manage the fleets efficiently. It does not only send the location, it also sends more information. All this information is collected in real time or near real time. Whenever I mention real time, it actually means near real time. So in real time, it gets data from all the individual buses to a central location. And then a lot of data analytics is happening behind that to come up with some information, which is then transferred back to the community. So the immediate next box on the left to the intelligent fleet management system is exactly the board which you saw in the previous slide on bus stops, which has the bus numbers and bus arriving time. So when you think about this, the location of every bus is being tracked, and the estimated time to arrive that particular bus stop is being calculated, and all this analytics is happening on the back end, and the information, the final information is being displayed. In some scenarios, in a simplistic way, you can imagine this as a distance problem, like the location of the bus is known from the GPS devices, and the distance from the location to the bus stop is constant, but there is another important aspect to look at, the traffic. So the traffic varies. So there needs to be some intelligent analytics behind this to at least near accurately calculate and estimate the time of arrival and display to the people. So that is one thing happening. And below that, you can see a digital board across the road, which mentions slow, and it has some images, which is the digital board which you earlier saw in the previous slide, which was telling you that this particular road segment is congested, something like that. So this information is a result of analytics which is done on top of the traffic scenarios, for which data is acquired from many different sources. Let's say the bus location is only sufficient to answer the estimated arrival time problem, but for this particular thing, only the location is not sufficient, and only monitoring the public transport vehicles, buses, is not sufficient to actually give information to people about the traffic scenario in real time across the road segments. So what is required is more data, which is collected from many different sources. One of that is the vehicle to information infrastructure communications box, which you can see right towards that, which means there are a lot of traffic cameras installed on the roads, which gives pictures of roads, and there are speed cameras which senses the speeds. And apart from this, there are something called loop detectors which are laid below the road, like a strap or something buried under the road. When any vehicle passes through the loop detector, it counts the number of vehicles crossing through the loop detector, and it gives us an approximate measure of how many vehicles has crossed this loop detector, and so we would know know some idea about the volume of vehicles in particular road segments, and then we can correlate or do some analytics using the volume, using the speed, and using the images by doing some image processing to extract the density of vehicles, simply the density of vehicles. It can go much deeper. This other information can be extracted, and all these are utilized, and a lot of analytics is happening on the back end to come up with the particular traffic updates which you see on the signboards across the roads. So it has a lot of scope for analytics. It is very smart, and there is more work on the analytics sector to do. And to the left of it, you can also see vehicle-to-vehicle communication, which is currently not much available, but we will speak about it in later slide. In future, it will happen when we speak about autonomous transportations. Vehicles will drive themselves, and they communicate with each other and also with the infrastructure to make decisions on their speed, their applying brake, or when to change, overtaking one vehicle, all this stuff. So there is a large amount of data being collected in real time, and processing is done in real time, and insights is being delivered in real time, which plays a major role in making the city smarter. In Singapore's case, making the nation smarter. And moving on to the next slide, this is more particular. You can see the advanced traffic light signal control systems. Let's say a normal traffic light, which is programmed to display red or yellow or green for a particular time, is there. But a smart traffic light should be able to adapt to the traffic scenario. There might be some situation where one side of the road is crowded with many vehicles, whereas the other side or the road crossing this perpendicularly does not have any vehicle. So in that case, a smart traffic light should not allocate equal amount of time for every signal. It has to be adaptive. So it has to get some intelligence about the number of vehicles or the volume standing, waiting for their signals in the traffic signals. And below that, you can see in-vehicle ITS telematics, which is a huge domain. There are so many steps happening inside telematics. Simply, I can say a very simple example of imagine like we can take Google. If you want to navigate to some place, you use Google, and Google tells you real-time traffic scenario. Like it shows you green or yellow or red on a road, giving you information about this place is crowded and all this stuff. This is one small segment of telematics, and there are so many. This also needs a lot of data in real time or near real time from as many vehicles as possible. Google collects data from every vehicle, every pedestrian who uses Google. Similarly, there are many third-party vendors who does related stuffs who are working on the ITS sector. They collect so much of data, and government in some cases also gets data from the third-party people and leverage that to come up with the final informations on that's being displayed to people on traffic scenarios. So as I said, these data sources is not only limited to the infrastructures like look detectors and cameras, and not only limited to the GPS devices. It also comes from a lot of third-party vendors who track different vehicles for their businesses, and collectively everything gives a good amount of insight on traffic and management. So on the right side, you can see autonomous vehicles, which is not much on roads in Singapore right now, but it is being tested. I have seen a lot of trials of autonomous vehicles, even took rides in them. They decently do a good job on overtaking and identifying pedestrians and stopping and speed control, everything. Sooner we can see them. There are more related to this. When it comes to energy related stuff, autonomous vehicles is more concentrated to because it can be green than the diesel or petrol which we use now, and it can make no errors like humans. So moving on, let's see some specific use cases. I need to rush it up a little bit. Let's take a first case for transportation planning. In Singapore especially, every day approximately 4 million trips is being done. I mean, 4 million travel is happening in buses every day. And the road segment of Singapore is actually approximately 12% of the total land surface of Singapore, which means the road transport is actually spacious and reliable source of means of commutation. And then there are approximately 3 million trips every day in trains. And there are a total of approximately 178 kilometers of rail networks being built, which Singapore expects to increase to 360 kilometers, which is in fact more than Tokyo and almost equal to London and other cities. So if that happens, commutation would be much easier than now. Right now, it is not much from the traffic side. There is no much traffic in Singapore, but still it can be optimized more. That is what Singapore is looking on. And they're also looking on continuously improving their signaling systems on rail networks. The current wait time between two trains in rail networks is 120 seconds approximately, which they are aiming to reduce to 100 seconds. Which means you can imagine in peak hours where a lot of trains is required, for every 10 minutes, as of now, Singapore is able to provide 5 trains, and in future, they are aiming to make it 6, which means there is only 100 seconds between one train and the other train. Imagine a case that if one train stops because of some malfunctions or it's not moving, what is the case? How many trains will be lagging behind? And how efficiently this transportation network should be managed so they will not end up in any difficulties and no commutation problems will happen to citizens. They have to ensure a lot. The analytics has a big role in not only the planning phase of transportation, but also in monitoring them and maintaining them. In fact, it is more required in monitoring than planning. So let's see on the planning, and also by 2030, Singapore aims to have 75% of their peak hour journeys to happen in public transport, which you can see from this graph is a bit contradictory, because the total motor vehicles used in vehicle is the chart you can see there. It's approximately 970,000, and the out of that, 62% of that is self vehicles owned by people, their cars and self vehicles, and then motorcycles and scooters contribute for 15%. And if you see the buses, it's only 2%, and rental cars, taxis, and stuff, and goods vehicles. But if you think, as of now, there is no much traffic, but still, if the number of self vehicles is reduced, obviously the traffic scenario can be much optimized. So Singapore is looking into that area, how they can reduce the self-used vehicles. Like they want to do something which motivates people not to buy their own vehicles but use public transport. They do a lot of stuff, and autonomous vehicle, as I said earlier, is one of that. In Singapore's vision, bringing up taxis and cars which are autonomous, which also acts as public mode of transportation. If that scenario comes, nobody needs a driving license to drive, and they don't need to own a car when public transport is faster, much convenient, and cheaper also. Nobody likes to own a car if that happens. So obviously the pollution comes down, the congestion comes down, the transportation scenario increases efficiently. It becomes much smarter, and especially for a city to become smart, one of the most important thing is the transportation, because it deals with everything. We transport goods and everything. So if the transportation is smarter, then it is easier to make the other sectors, or at least few other sectors, smarter than a scenario when transportation is not efficient. So this graph actually tells you the MRT, which is mass rail transport lines. The dark lines tells you about the current MRT lines, train lines, which is existing, and the dotted lines are the ones which is in plan, which Singapore will achieve by 2021. So after 2021, there are still rooms for planning. And for all this planning, there has to be a lot of data analytics. The country has to deal with a lot of data to make decisions. And what are those data? This question comes now. I have showed you a device for tapping the passenger cards, which is used in buses. A similar device is used in train stations before you enter. It's an integrated system. So every trip by every citizen in Singapore using public transport, be it bus or train, is being monitored. So there is a saying that you cannot manage something which you cannot monitor. So everything is being monitored, and as we saw in the previous slides, there are 4 million bus trips and 3 million train trips every day approximately. Singapore also knows the distribution of the travel. Like they can come up with a rough idea of what is the route people are taking more. In other words, which route has more number of trips and which route is being congested all the time, which needs some work on that. And people travel from where to where over time, on which time of the day, on which season, and all these patterns. They have to analyze and understand so many different patterns here so that they can do a what if analysis, which falls inside the prescriptive analytics, which we saw earlier on. If I introduce a new line here, will it affect the congestion scenario? Will it be a good remedy, or is there any other route or any other way where I can actually concentrate on laying these new lines, which improves the commutation scenario efficiently? So that is the scope of analytics behind this. So I can say analytics is the is a very important technology behind this plan. And looking some functional overview on that, we are not going much inside algorithms or coding or technical, we just see the functional steps. So the data they acquire from the smart passenger cards, and then they do some analytics, which results in transportation plans, informed decisions. And some of the questions for your understanding, which they try to answer in the analytics space are listed below. Something like, as I mentioned earlier, which is the crowded road, and there is another scheme in Singapore, like in peak hours, usually the public transportations are getting crowded. I'm thinking, putting some thoughts on this. To avoid the crowd, Singapore has announced some free travel trips before the peak hours. So they need to come up with answers to some questions like between what time and what time is actually the congestion happens, and what is the time duration in a day they can allocate free travel options, they can provide free travel, and what is actually the routes. They cannot just say anywhere you travel is free between this time and that time. So they need to know over time the pattern of travels, and they constantly need to change the routes for which they give free travel and everything. So because the travel pattern is not same all the day. When time passes, everything changes. So it needs to be monitored, it needs to be predicted in case if necessary, but monitoring is very essential, and then re-plan all these steps constantly. And other questions being, when is the right time to increase the frequency of trains, and what is the particular route for which the frequency of trains needs to be increased. It cannot be random, it has to be associated with reducing the traffic congestion scenario or improving the commutation efficiency. And it also answers some questions like, what are the crowded train lines, what is the wait times between trains in particular stations, and can that be worked on to reduce the wait time, all this kind of analytics. This is the first case. We have one more case, we will go a bit more deeper. This I chose this particular case, even then it is a small problem to address, because while addressing this, we will come up with other difficulties, which we will also understand. So this is hassle-free parking to avoid congestion. The scenario is, the image you see here is a sample image. It's not from Singapore, just to give you an idea about what is the problem. What happens is sometimes, like every car park here, not only in Singapore, in many countries, different car parks will have different parking rates. So people's mentality is to choose the lowest price, and everybody in that region or regular visitor to that region will have a good idea about what is the parking charge for different parking lots or parkings in different buildings. So most of them tend to park in the lowest one, and if everybody goes there, then parking is full, there is no space. There are many a time when actually the parking is full and the drivers start creating congestions just outside the parking lots and queuing one behind the other, which causes congestion in the traffic road scenarios to other people, and it creates a lot of mess, unwanted mess, which can be addressed. So thinking it is actually one good problem to address to make something smarter in everyday life. So we take this problem now. So how does this is addressed? Is all the parkings here are electronic parking systems, which means they know how many vehicles are inside at a particular time, and we also know the total number of parking lots in particular parking, so we can always calculate the availability. So that data is being transformed or sent to some central location, especially some ITS businesses, small, medium scale businesses, ITS sectors, they work on these areas, collecting data, all this data, they accumulate the data. And you have seen in the previous slides an image which I marked in red, which is the parking lots availability information for people. That system is actually the live parking availability, which is smart, but the system can become much efficient here. That particular board gives people information about the current availability of parking. Let's say I'm traveling, I see the board, and the nearby 3 or 4 car parks is all full. Then I know I should not go and stack there. I can change my route, but I have already traveled uh, a certain distance, keeping this particular car park in mind, which is a waste of time. But which means there is still room for optimizations. So optimizing this is the problem which we are taking in mind now, and we will see some solution for that. So with this data, we can analyze that, do some descriptive analytics on top of that to understand the behavior patterns of car parks, which will be different in cases of uh, residential buildings and commercial buildings. Let's say, take a shopping mall, it will be fluctuating up and down between time. But if you take residential buildings, usually people go to office in the morning and come back in the evening. It's much usual. It looks like a bell curve. If you, it's a normal distribution mostly if you draw it. But then in shopping malls or other commercial buildings, it might be drastically varying up and down. It's different behavior for different car parks. But we can always understand the behavior to a certain level, not with 100% accuracy, but to a certain level, we can generalize a model to understand the patterns and utilize that to come up to the predictive analytics phase, where we try to predict the future lots availability in a particular car park. So when we do that, we have many different problems because not every driver will reach a particular car park in the same time. Everybody comes from a different location. Everybody reaches the car park in different time in future. So in that case, we need to think on some models which should be able to predict the future lots availability for a varying time window, which means from the machine learning point of view, the training of these models is not very simple. Like we have data for equal time intervals. Yes, we collect data in equal time intervals. But what we predict is not for the same time window, but it is for varying time window in future. So that is one problem we face here. So we also need to know for every user a scenario to estimate his travel time, which brings in another problem, which is the traffic congestion or live traffic situation. If imagine a navigation system which tells you the route, gives you a route to reach your particular destination, and it gives you some options of nearby 4 or 5 car parks, and the current parking availability is enough, but still it gives you some predicted values for the time you arrive to that particular car park, which varies. And based on the route you take and based on the particular day and congestion scenario, the traffic in your particular route may vary anytime. And one of the most complicated problem which the ITS sector, the navigation sector is facing is to estimate the time taken for your trip accurately. It is never close, and it is very difficult because the traffic scenario drastically changes over time. So in that case, it has more to estimate the time of arrival. You also need to utilize the data from other sources to work on the traffic scenario on the roads, and then efficiently come up with the efficient time taken for your travel. And for that particular travel, you need to come up with the predicted value and display it inside the navigation system. So this is the objective of this small problem addressing. So we saw a lot of difficulties here from the technical side because the behavior of every car park differs, and in commercial car parks it drastically changes, fluctuates. So the model has to be reliable, and one thing. And the second thing is the model has to be reliable and it has to predict values in future for varying times. These are two problems which we need to address. Some way to address how it is being addressed are using these two concepts which most of us is aware, and for those who are not aware, ensemble of models is using multiple models, and it is like getting suggestions from multiple models to decide on something. Let's say if I need to buy a stock, I go and speak with my relatives, my friends. I get inputs from many people. Somebody will tell me, okay, buy it, it is good. Somebody will tell me it is not good, don't buy it. Collectively, I get it, and then I come up with some decision. Let's say out of seven people out of 10 tells me that, okay, you can buy it. I get more confidence on that. That is the way ensembling of models works. We use multiple models to do the same task, and then the final result will be a function of the results from individual different models. It is a function. For simplicity, we can say it is an average, or it is a, in case of classification, it is a voting. But basically, it is the result of the final model will be a function of the results of individual models. And this is used to address the reliability problem. Ensembling models will help on the bias variance trade-offs. And when we come to the other problem where we need to predict for different time windows, we go for hybrid models. Because our training data is time based on equal time windows, because the sensors would send you data on fixed time intervals. We use that to predict a future value for that particular time window, and the output from the model 1 will go as input along with other input values to the model 2, which will take us to the next time step, in which case the error from model 1 will also accumulate with model 2. So we go as many steps as we need to reach the final model, which gives us the predicted value for that particular estimated time of arrival for every user. This is the way it is being addressed. It has a lot of complications on, because the error from one model will accumulate to the other model. It needs to be reliable, and so many architectural changes has to be done. And there was a lot of research done on this by the leading research institute in Singapore, which is called A-Star, and also big companies, MNCs like Continental, and many other ITS solution providers together. So this is one other case to understand the intensity of machine learning knowledge required to solve these kind of problems. It's just an example, it's not the only case. To understand the scope for machine learning and advanced analytics in smart city domain. The previous problem will give you an idea about what is the intensity of knowledge required for advanced analytics, or for monitoring or planning, and this will give you an idea about what is the intensity of knowledge required in machine learning aspect. Moving on from here, so we have discussed two cases. Coming to this slide, there are many other projects being done, research is being done. For example, taking a smart home, we have Internet of Things now, where we have smart fridges, which tells you when your bottle of milk is going to be emptied, it's going to be over, and which tells you more information inside. We have smart appliances, where from your office you can switch on your fans, ACs. By the time you reach, it will be cool. And we have appliances which makes chapatis for you. You can just send a message to that appliance from your office, make me 3 chapatis, and when you reach, you will be ready to eat. And all these kind of smart home appliances, all these are being integrated using the IoT steps, and applications are being built for this to make a particular small area, which is a home, which is only your home, smarter than it was before. And on the smart society side is the people who become smart and using the internet and leveraging the stuff available in the net, deals mostly with the people and society. When we come to the smart care, there are a lot of steps being happening. One example I would say is let's say people going to hospitals waiting for a long time in queue to get their appointment and visit the doctor. Somebody needs to get a bed. They need to get admitted in the hospital. They need to wait for a long time to get their particular bed allocated to them. It's a common problem which is happening. Many stuffs are happening, but I'll tell you this example. There are models being built to monitor the queues, monitor the wait times, monitor the number of counters open at particular day of time over time, and use this historical data to come up with some patterns, understanding some patterns, and using them to predict the future Q values. Not only doing that, it becomes prescriptive when they also do some what if analysis on the number of counters, that optimum number of counters that needs to be opened in a particular day of time, so they can efficiently manage this queue process and bed allocation process stuffs. And this system will finally tells the hospitals to something like this many number of counters should be open at this particular time of the day, so your the wait time for patients will be optimized, reduced to a maximum level, possible level. So that is one example which is happening here. We can speak more when it comes to cross domain. I'll tell you later. When it comes to smart buildings, there are a lot of stuffs: installing cameras on every floors, monitoring the videos, extracting information from the videos like density, number of people moving here and there, and then you can install water sensors on the tanks. You can install, let's say, in commercial buildings or office buildings, there are a lot of ammonia sensors being installed inside the restrooms. So it will trigger an alarm when it is actually required to clean a restroom, rather than fixing a person to clean a restroom in fixed amount of time. He goes and cleans the restroom 5 times a day. When it is actually required only 2 times, it can be 2 times. But when the times it is required to clean more than 5 times, has to be it has to be varying based on the real requirement, which is managed with these kind of analytics sensors and everything, and the smart lightings inside the buildings. When people come, they switch on, switch off all the stuffs and all the regulating stuff inside the building. When we come to the energy sector, as we spoke earlier, energy is a major concern in smart cities. So especially Singapore is looking into introducing electric or hybrid vehicles more, encourage people to buy them by giving concessions on when they buy hybrid vehicles or electric vehicles, because it becomes greener than before. And the ultimate aim is to replace maximum number of cars and everything with taxis, which are autonomous cars serving as taxis, which people can use, leverage for optimal cost, less cost, convenient to travel, and everything satisfied, and reduce the number of private vehicle count, as we spoke earlier. So this is one thing on the energy sector. On the retail, a lot of steps are happening, like monitoring. There is especially the video analytics, having video cameras and analyzing the video contents to understand people flow to different places and understand what are the products people are interested. So they can be bunched together for doing some association analysis and giving offers on bundles of products if bought together, and also on reworking the arrangement of products. Let's say if people are interested in if we find people are interested in a particular product which is placed in a corner somewhere, the retail shop will be able to, after understanding this, they will be able to reorder the location, the placement of the particular product to easily accessible place kind of stuffs. This is mostly on all this stuff. We're running out of time already, so let's move on to the next slide. What will be the future if you see? As I said, autonomous transportation plays a major role in smart cities everywhere. Every city will now look into the autonomous transportation. Singapore is even planning to make their public buses autonomous. As starting steps for that, there are few buses being brought to Singapore and they are being tested. They are running autonomously. It's happening. And the other thing is preventive policing. imagine a case, cities, in Singapore, most of the case is camera surveillance. So when we have surveillance, we have video coverage everywhere, CCTVs everywhere, we have images on usual places where there will be more crowd. Um, the police department will be able to monitor that and use the video information, do some video content analysis, and extract some information like some aggression being happening in a place. Let's say if some aggression is happening, and the system can intelligently detect that and send alerts to the police that there is an aggression, so they can come to the place and prevent some disasters or some riots or what is happening. So it is on the preventive policy. It's not only that. Let's say if combining with the people's support, let's say if person X is being kidnapped in a place, and somebody watching that can send a message to a particular number or entity which is being published, which is the system actually, and then the system starts monitoring from that place based on the message triggered, doing something on the vehicle in which the person is being kidnapped, and getting the vehicle numbers, license plate number, and then associating it, integrating it with the person data based on Singapore citizens' personal data side, if authorized, and understand who is the person inside the car doing the kidnapping and where exactly is the car moving in the road segment, and how efficiently they can catch the person and stop the and rescue the victim before something bad happens, something like that. And when we come to the cross-domain analytics, let's say we saw the intelligent traffic management system, which we can combine with hospital and think of a use case. In future, when let's say there is an ambulance which needs to reach a nearby hospital, it's an emergency case, and in this case, it can be linked with the data and data analytics stuff in the traffic side, where we have intelligent traffic control systems. The control systems can be notified that this particular vehicle traveling in this location needs to reach the hospital location faster. So in accordance to the current location and the travel location of from the ambulance, from the GPS devices in the ambulance, the intelligent transportation control system can be taught to modify the signal lights and change and make it much easier and faster for the ambulance to reach the place. It comes in future scope of cross-domain analytics and much advanced, which is being in research, which we can definitely see in future. And on the energy optimization, we spoke a lot. On intelligent assistants, we already have seen a lot, like IBM Watson, and we have seen Siri, we have seen Cortana, and many intelligent assistants. Intelligent help desks will also classify in this case. We have a lot of companies handling their low-level questions and tickets using intelligent bots, which can answer basic or routine questions by themselves, by saving time, especially. And looking at all these things in future, as we are expecting exponential growth on data, cleaning the data could alone become a huge industry. So if we work, if I say I'm very strong in cleaning the data and all these stuffs, then that would be more sufficient for me to be an efficient professional in that particular domain. Because when time passes, we will deal with a lot more data, and data cleaning is going to be a hectic process which needs much expertise. And obviously in future, expertise will increase, people will learn more, but still there will be struggle in understanding and utilizing their skills in the right way, because it's all related to research, sometimes trial and error. And this is my last slide, and then we can move on to the questions. So what we saw about what can we see in near future, but what can happen in far future, I would say imagination is the limit in this case. We have seen movies like the pre-crime stuff, which actually comes in the movie Minority Report, where they identify they predict the crime which is going to happen, and then they prevent it. It could happen. Who knows? Who knew that we would have an intelligent system by today? But we have, so it can happen. And we can also have a robot being a friend to a human, walking with him, speaking with him, telling him stories, being a mentor or a teacher for him. Or even that robot can be everything for a human. As a mentor, as a friend, as a companion, everything. As a play buddy, everything. And the transportation with autonomous vehicles could become something like this. Even now in Dubai, they are testing with flying drones, which can be used as taxis kind of stuff. So anything might happen in future. It's all limited to our imagination. The gist of this is we have a lot of scope for analytics and machine learning works. It requires, especially in smart nation and smart city domains, it requires a lot of expertise in machine learning and advanced analytics. So with this, what we have discussed today, we can also think about what we need to concentrate and how should we improve our skill sets to be someone on the top lists. And that's all for my presentation. And you can always connect with me in my LinkedIn for further questions and everything. Now I will take up some questions. So I have two questions earlier from two people. I will try to address that first. The first question is from Venkata Shrikant. He has asked actually that recently he has started working on smart city projects by using street lights power consumption data. He's asking me to. He's asking that if we can develop any good use cases on the energy analytics sector and some information on using advanced analytics for electricity, smart bins, natural disaster control domains. For your question, I would say we spoke a lot about energy analytics. It is very essential for the future for smart cities. I would suggest you, if you are looking into any kind of research in the energy analytics field, I would suggest you to initially concentrate on the energy analytics for some commercial buildings like star hotels or office buildings, and giving them information, because by doing this, you can try to sell your solution to these businesses and these commercial places, and they will be able to afford it for some money, which you can use for your research and moving further with your research. Rather than going for the street lights and doing some research, I would suggest, just a suggestion, I would suggest you take up with some commercial buildings first and try to sell it, and use the money to further your research. And for your question on the natural disaster control, I don't think we can control the natural disasters, but we can always monitor when something bad happens and take some actions to prevent the losses or reduce the losses at least. So in that case, for some use cases on this scenario, if you're thinking about making some commercial business out of this domain, I would suggest you to do a brainstorming on monitoring the near real-time natural disasters. Either you can monitor through news websites, earthquake websites, or you can also monitor through social media about conversations. But then you need to put a lot of effort on natural language processing, text analytics stuffs to extract information. And then you can put some thoughts to come up with some models, some business ideas. Like you can try to sell it to some businesses, especially on the supply chain domain, telling them that you are able to monitor near real-time natural disasters, and because they are in the supply chain domain, you can predict, and you can give them suggestions or insights on predicting their supply chain disruptions and doing some preventions by doing some correlations analysis with their historical losses and all these steps, and you can put some thoughts on these areas and move on. And there is another question from Niranjan. He was asking, though the cities in India require a good amount of analytics, but cities do not have money to fund analytics projects, analytics studies. So even for smart city initiatives, the government is paying. So how it can be solved? From where cities will generate money to fund the analytics projects? This is a good question. I would like to put some thoughts on it. See, for you, for anyone with this thought, I would say, if we are looking to bring some change in the community, it has to start from us. That's what I believe. So, for this particularly, everybody should not look for some sorts of funding to start with some smart city initiatives. I would say the usual cases how it is actually happening. It is mostly dependent on entrepreneurial minds and efforts. Usually, entrepreneurs come up with some startup ideas on the smart cities initiatives and any analytics on any smart city related startups, and then they will build some MVPs. They will try to sell it to businesses to get some money out of it. As I said, you can build some situational awareness platforms which monitors something and then gives you awareness about the situation. That would be the very basic stuff. You can build something like that and start selling it to companies. When you sell it, you will get the money to invest for your researchers further, and then you can slowly scale it up. So that's the way you can solve it. If we expect for funding or something, it might not happen. Rather, if you are really interested, you have to do something like take initiative, do something, try to sell it, and manage your financial constraints out of that. Because it's not only the government's responsibility to make city smarter; it's the citizens' responsibility as well. And of course, there is a risk coming up with ideas and starting with startups. It can fail. We need to put a lot of efforts. Initially, there is no profit. I understand that. But still, if we are ready to take risk, only then we can be successful or be extraordinary. Okay. So let me try to. Oh. My screen is actually passed. Deepika, are you there? Are we running out of time because we are half an hour delayed? Can we continue with some more questions, or is it time we need?
No, sure. We can take a few more questions. There's no issue.
Okay.
Can you see the Q&A? Are you able to see?
Yeah, I am looking at the Q&A now. Prediction done. Many people are asking about the technical stuff inside the projects being done. I think we should not go into technical details right now because not everyone is requiring technical stuffs in this audience group. Is traffic jam is due to only one vehicle, or the horn sound irritates everybody? And the horn sound they pass through. Okay, I'm looking for some relevant questions which I can answer, which will be useful. Okay, there is a question like which tools can we use to mine data and apply it for machine learning? So this is one thing which will be helpful for you to start learning some tools. And when it comes to data analytics or machine learning, it's not about the tool you use. You can utilize any tool which is you're comfortable of, but the widely used tools here, in case of visualizations or creating dashboards or analysis or interactive analysis stuffs, The widely used tools are ClickView and Tableau. Mm, Tableau is very easy to learn, easy to develop. It's just drag and drop. The UI is better. When compared to Tableau, ClickView, its engine is bit faster, and you have some scripting flexibility in ClickView. So I would not say one is better than the other. Each of them have their own plus. So you can concentrate on both of them. It doesn't take much time to learn them. So most widely used are ClickView and Tableau. There are a lot of things to learn inside Tableau. If you think about visualization steps for any particular product, it's not only creating the visualizations. In case if it is a web application, you need to think about integrating uh, the visualization tool into the web application, and then you have to manage the single sign-ons, the data securities, the authorizations, and it has to be for the end user. It should be like seamlessly using all the integrated tools, like he's using only one tool. So we need to learn a lot of things inside that. And for the machine learning, generally people go with Python and R because both of them are easier. If you are uh, For me, I use Python especially. I have done some R codes as well, but I feel I am familiar with Python, so I go with Python. But I would suggest, if you are starting, or if you're in the middle stage, you can use Python or R. If you are an expert, then obviously they go for C++, something like that, because it's faster. Uh, So I think that is how smart electric meters were conceivable. How should I start? And some other tools you can also explore, or some platforms like Knime, which is an open platform, KNIME. You can have a look on that, which is good. And you can also use software tool called Weka, WEKA, which is developed by a New Zealand university, which has so many algorithms inside, and it's faster to implement and get some idea about which model works better for your need, and you can place that. And now the Weka platform is also integrated with a platform called Pentaho. If you have time, you can also look into Pentaho, which has so much of integration ability. You can integrate a lot other tools with Pentaho and leverage all of them together. What is the best tool to start up with machine learning? Again, there are many. If you are a complete beginner, I would say you can start with R, because there is a package called Rattle inside R, which you can start with, which is a UI based machine learning stuff. For a starter, you don't need to script much. You can utilize the Rattle to work around some stuffs in machine learning, and then you can also extract the script for what you have worked using the Rattle application. Then if you go through the scripts, you will understand something, and slowly you can move on to scripting in R. R is a very good scripting language. You can continue if you wish. If you have some knowledge on Python, I would suggest you can start with Python for machine learning. Is there any webinar specifically for deep learning and artificial intelligence? Okay. For this, I cannot say webinars, but if you're interested in deep learning and machine learning stuffs, to know more on the back end of how algorithms work and how can you choose which algorithm has to be used for which problem, which kind of data, I would suggest you start with Coursera course by Mr. Andrew. It is from Stanford University. It is a very good basic, and if you start with that, you will understand most of the working concepts behind algorithms, and then you can then move on to deep learning, because you need to know neural networks, how it works, before you go to deep learning. So And there are a lot of packages as well, like Piano, TensorFlow, and everything for deep learning. But then I would suggest you start with the Stanford University course, which will be very, very useful in understanding concepts, which gives you the edge when compared to the other data scientists out there. And then, can we get an opportunity to work in Singapore IoT analytics? Obviously, it's difficult to come into Singapore. I think a lot of people will have this question in their mind by this time. Um, if you're looking for some job inside Singapore, it's obviously difficult because the rules now on from Singapore side is very strict. A foreigner being staying in foreign countries coming into Singapore is very rare, but I will never say it is not possible. You have to get the right connections. You can utilize LinkedIn. I would suggest you LinkedIn. Improve your network, get connected with many people, create a portfolio for yourself on your works and everything. Create something which you can showcase and utilize your networks to come inside Singapore. That's the good suggestion I would give you. But there are a lot of odds on the employment pass processing and everything. But still, it's worth to try. You can try if you're really interested. I would suggest you build your network in LinkedIn. So, somebody asked Rattle question mark called Priyam. Yes, Rattle, Rattle. Rattle is the package name inside R scripting. You can install the package. Once you install R, you can install the library Rattle. And if you run the library Rattle, you will get the UI popped up, which you can utilize to do some initial analytic steps. And there are books especially for Rattle in R. You can look for it to start with. It will be very good. What is cognitive computing? Okay, cognitive computing is, let's say, if we impart human intelligence to a machine and teach the machine to take their decisions themselves, imitating a human, then we could say it as cognitive computing. For example, I don't know if you have come across IBM Watson. It is actually a cognitive computing stuff. If you want to know more, you can Google for IBM Watson, which is a supercomputer. And IBM has a website that explains on how Watson behaves, and they also explain about what is cognitive computing. You can search for it and read more on cognitive computing. And then, can we tell next 10 years will be ruled by machine learning? Okay, I won't say it is ruled by machine learning, but machine learning, smart city, analytics, advanced analytics, all these are buzzwords for now. In every point of time, there will be different domains in peak. There will be opportunities changing here and there. But this machine learning gives us an edge of teaching some human intelligence. It's nothing but incorporate your knowledge into a machine. If I build a machine learning algorithm from scratch, if I teach some intelligence to machine all alone by myself without other people's help, then I would be actually incorporating my knowledge. The model can also be biased to my knowledge. So that's how it works. There will be definitely a lot of opportunities in the next few recent years in machine learning. You can always utilize this big time, provided you learn the right things. Machine learning implementation is very easy. There are a lot of libraries here. You can learn it very fastly to implement an algorithm. But the thing you need to concentrate is how the algorithm works and how you can tweak the algorithm to improve the efficiency based on the problems you face, and how can you modify the algorithms based on your needs. Something like have an existing algorithm, do some modifications intelligently so it works better. Kind of things is what you have to spend time and learn. And moving on to next question. Do machine learning will take over AI? So which should be chosen as future professional site? Okay, I wish to clarify something. Machine learning is a subdomain of artificial intelligence. You cannot put a statement that machine learning will overtake artificial intelligence, because if machine learning is growing, it also means artificial intelligence is growing. I feel that many people associate artificial intelligence with robots, with autonomous vehicles, a robot moving and sticking by itself, um, and machine learning with some algorithms which predict something, time series forecasting, weather forecasting, all are machine learning stuff. But even if you go to AI, the robot has to learn something. If you want to teach a robot to answer you something, the robot needs access to some documents from where it can fetch the relevant documents from your question. Let's say I'm asking a question to a robot which answers to me exactly like a human. What is happening on the back end? It's AI, it's also machine learning. It understands the text, which it converts my speech into text and understand what is my question, and fetch the most relevant document from its knowledge base. If you don't have that knowledge base, it cannot answer you. It fetches that and extract the required information to answer you on some hypothesis working behind, on some scoring systems, and then it puts the sentences based on some conversations which it has in its knowledge base as well, and answers you as speech. That's what it happens. So everywhere machine learning grows, AI also grows. That would be the answer. I think it also answered the question how machine learning differs from AI. And then, will I have advantage in machine learning considering my experience with embedded systems? Definitely you will have an edge because you also know about the embedded systems, how does it work, so it'll be easy for you to pick up or work on a high level architecture from let's say person A has experience in embedded systems and person B don't have experience in embedded systems. Person B will be able to come up with best architectures, even better than person A in machine learning aspect for a particular machine learning problem. But let's take IoT in that case. When you think about overall architecture, person A will be able to handle the architecture for the sensors, embedding them, and a high level architecture. They can handle both the sectors. So each of them has their own advantage. But if you can compete in the machine learning area to another data scientist who doesn't know embedded system, you definitely have an advantage. But only because you have embedded system knowledge and you cannot compete in machine learning with another person, then you do not have the edge, definitely. Computer vision in analytics, cognitive computing, and IoT. Somebody, Mohinder asked me to discuss some points on computer vision, analytics, and cognitive computing. Okay, let's take the scenario of autonomous vehicle. How does it work? It collects data from different sensors. Majorly, many autonomous vehicles are using lidar sensors to collect data about their environment, and then use that information data to reconstruct a 3D environment so it understands where its current position is. Something like send some lidar rays, get back data, and use that data to construct a 3D map around the vehicle to understand if there is anything standing in the way or if any moving object is crossing its way, to understand the environment. That's how it works. So in this case, the lidar sensors are very expensive. Another alternative source for this can be computer vision. There are advantages, there are disadvantages in this area. It's still a lot of research is going on. Computer vision with the help of some stereo cameras, and if you process the stereo images to extract information of the surrounding, And if you can utilize that information to create a surrounding, a 3D environment around the vehicle, you can try to replace the lidar sensors, which will be very difficult because in dim light, processing the camera images, extracting information is going to be less accurate. But this can always serve as an additional assisting system to the lidar sensors. The camera images can be useful. So there is definitely a big scope for computer vision analytics, especially many people I meet learns OpenCV in different languages and try to utilize that to do some image analytics and video analytics, which is not only used uh, in the transportation intelligent vehicle sectors. It's also used in retail centers. As I said, the retail shops use some video analytics and it can be used in many stuffs. Like a simple application you can start working on this computer vision is to feed some images and of car license plates and try to extract the license plate number from that. You can start with that. Or there is a data set in the web called MNIST dataset, which teaches you about the character recognitions. It would be a best start on this sector to work on. Then some other questions. I see some big questions which takes time to read. Which role is computer vision going to play in the use cases we discussed today? So in this webinar scope, we spoke about the vehicle-to-vehicle communication. I mean, we spoke about the autonomous vehicle. So it can be used for, computer vision can be used for the environment reconstruction, or then let's say you can use a camera and computer vision to teach the autonomous vehicle to look at the traffic lights and understand it's a red light or green light, whether I can move forward or I should stop, something like that. If we predict and showcase the parking availability to the users, wouldn't it spike the parking occupancy during the period when the parking lot is predicted to be less occupied and vice versa? Obviously, yes, right? We need that. We actually want to redirect the people to less occupied car parks, so we can control the congestions, we can avoid stacking of vehicles outside the car park. So that's the main aim, right? It obviously will happen. That's what we are aiming for actually. We are trying to save the user some time on save some time for him to not travel in some direction, some route. At the end, he is going to face some parking deficiency. So in the middle, he can reroute him. He can ask the navigation system to give him a better alternate route, which he can use to occupy the less occupied parking space. That's the aim. So as per your question, it will happen. That is our aim. How vehicle breakdowns are handled? Okay, this is a good question. So when a vehicle is broke down, in Singapore's context, somebody sends a message or the cameras will detect that, or based on the vehicles accumulating one after another and a sudden congestion happening in a place, the government is able to know that some traffic incident has happened. It can be an accident, it can be a roadwork, or many different types of traffic incidents, but it knows there is a traffic incident. So as soon as it happens, operators will double check that and confirm the traffic incidents in their portal, which is published as open data to people to use. The businesses will also are also using, a lot of businesses are using them. In fact, even in Google, you can see current traffic incidents in Singapore, which data is publicly given by the government. It's our approved traffic incidents by the operator. So once it is detected, it's being plotted on maps, and from there, From there, the estimation on the current traffic congestion is calculated, some estimations on rerouting them and suggesting the users alternate routes. All these analytics are happening from there. So that's how breakdowns are handled here. To remove the cars, as soon as there is a breakdown, some tow trucks will come there and move the vehicle to the leftmost lane, or in some expressways there is a leftmost lane which is actually not for usual commutation. They move the vehicle to the leftmost lane and then the traffic resumes back to normal. That's how it is handled. And when you look at this particular case, there are more opportunities either, because the public data set is being populated only after the operator confirms the traffic scenarios. But if you are an ITS company, or if you are someone who collects data from GPS devices on roads in near real time, and you process that, you will be able to monitor vehicles congesting in a particular road segment at some point of time, which is when actually the incident has happened. But if you rely on this published sources, it will take some time for the operator to approve. So there is a room for improvement here. There is a research opportunity here to work on some kind of algorithms or scripts or system that can reliably detect and say the operators, even if there is no one, the camera cannot detect it, so nobody is sending messages. You can develop a system that sends alerts that identifies congestion based on sudden slowdowns of many vehicles in a particular road segment, and then create some alerts so the operator can publish this data set faster in case every even 30 seconds faster. If some incident is published, it saves a lot of stuffs. Imagine in a highway traveling 80 km/h speed, in 30 seconds you would even cross one exit from the one or two exits from one side of the road and cross them. If you did not cross that, you could always utilize that exit to come out of this particular expressway and move into some other way, reroute them. It will be useful. All the applications for ITS are automated and they are monitored on real time. Okay, cannot say all. ITS deals with a lot of things. Let's say transportation intelligence. If I work for some logistic customers and I'm analyzing their data, their delivery is their main business. They're delivering different products to different places. And if I'm doing some intelligent analysis on their routes, their trips, and telling them what alternatives you could have done to save, but you actually spent this much on this, you could save by adapting this kind of stuffs, which is not done in real time, which is kind of a reporting, intelligent reporting, descriptive analytics stuffs, which they can utilize to make changes in their future plans, which I can say it is automated, but it's not monitored on real time. Similarly, not every application is automated. It is best if it is automated because it saves time. We don't need human intervention, but not everything are automated. What is hindsight? Please repeat again. So that is in a slide where we saw hindsight, insight, and foresight. Hindsight is something that behind time, what has happened already. If I provide you some Excel report with 1 million rows of data coming something, it is very hard to instantly identify something out of that. So we do some descriptive analytics, come up with charting, some intelligent visualization of that to interpret the information and understand. So that is something which has happened behind time, and we get some sights out of that. So it's hindsight. It's a self-explanatory term. I think we have covered many questions, and it's already 1 o'clock in Singapore. So Deepika, are you there? Hello? Anyone is online in the chat? Hello, Deepika, are you there? And anyways, it's been beyond the expected time. You have been wonderful audiences interacting with me, asking questions, staying for a long time. Thank you all for being there. In any case, if you have more questions or you need to speak with me, you can always connect with me through my LinkedIn profile, which I've mentioned earlier. You can just search my name, Hariharasudan Balasubramanian, and you will be able to find me. Next class, I don't know about next classes stuffs. We will work it out if required. Hello, Deepika, Sunil, someone? Hello?
Yeah, Hari, hi. I got disconnected in the middle, so
It's
let me know
okay.
if. Yeah.
It's okay. So we discussed a lot of stuff, answered most of the questions I could answer in this time. And I have asked them to connect with me through LinkedIn if they have further questions and if they need to discuss more on this area. And yeah, we have all been wonderful audiences, and thank you for the opportunity. Thank you, Deepika. Thank you, everyone.
Thanks, Hari. Thanks, everyone, so much for joining us. And we'll get back to you very soon, dear audience, with wonderful webinar sessions ahead. Thank you, everyone. So, shall we get off for the day there? Okay, yeah. Bye.
Okay, bye-bye. Thank you.